Hey, welcome back to Math is Easy Step by Step. We are continuing the extra skills knowledge of finding zeros of functions, and right now I'm continuing going over FOIL. First, outer, inner, last. And there's many different type of examples I'd like to show you. And you need to understand how to perform FOIL because this is how you check your answers. This is the inverse or the opposite operation to factoring. So once you've factored, a equation or expression, this is what you get, right? You get terms in one set, two set, three sets of parentheses sometimes, and a term outside or multiple terms outside. And so this would be a factored form of an expression or equation. So now by foiling these terms, just like distribution, uh, you should end up with the exact same expression or equation that you started with when you first started to factor. So this is how you check your answers when you are factoring. Let's just get right on into it. We're going to distribute this x squared times the x to the invisible 1 power. Also x squared times the negative y to the third power term. And that is essentially kind of what we're doing with FOIL. We're distributing. So step 1, multiply terms outside the parentheses with each term inside the parentheses. And I'm showing you that here now. So again, 1x squared times 1x right down here. I'm showing you the invisible ones. And this one is assigned to the power of 2. So there is no invisible 1. This is raised to the second power. But this is 1x to the invisible 1 power. You can write a 1 here. Or you can even write in a 1. I use dot, dot, dot as a form of instruction. Okay? Then we're going to distribute or multiply this x squared term times this negative y to the third power term. And that's what I'm showing you here. 1x squared times 1y cubed, and I'm going to add a plus sign between these two terms. You can look at it as a plus 1x squared or just a plus sign and a positive 1x squared. Now, hey, step number 2, let's combine these like terms. Let's combine like terms. And so remember, in order to have like terms, you have to have the same letter, that's the variables, and the same exponential power if you're going to add these terms. But since we're multiplying, that's okay. We don't need like terms. That will come a little bit later in another example. 1 times 1 is 1x. The rule is you got to add those exponents when you multiply. So 1x times 1x is 1x to the 2 plus 1, the third power. Plus plus 1 times 1 is 1. XY is attached through multiplication. Remember, any terms together means multiply. And since these are not the same variables, we're not going to add these exponents. We're just going to rewrite them attached to their same variables or letters. X has the power of 2. Y has the power of 3. We're just going to leave it there. This term has been simplified. So let's review. And if I'm going too fast, go ahead, pause, stop, rewind. Let's review what makes like terms, right? Because you can only add and subtract like terms. So like terms have the same base, x, y, z, a, b, right? They have the same variable. You can only add or subtract like terms. So like terms have the same variable. They also have the same exponential power. So x squared and another x squared would be the same letter, the same variable raised to the same power. Or a cubed, or a squared b cubed, right? These are examples of terms with exponential powers, right? They're not like terms because they each have a different letter. But these are just examples of terms with exponential powers. So in order to have like terms, it's got to be the same base and the same exponential power. Moving on, when you combine like terms, you can only add or subtract like terms. So adding positive and negative numbers, right? Like terms. They have to have the same letter, the same variable. So here you can see 1x plus 1x. They're the same base, the same x. They're both to the same exponential power of 2. 1 plus 1 is 2x to the second power. And some of you might be thinking, hey, why aren't you adding these exponents up here? Well, you can only add exponents when you multiply, and the base is the same. Okay? I'll say that again. You can only add these exponents when you multiply. Here I'm adding. 1 plus 1 is 2. Then I just rewrite that x squared, all attached through multiplication. Or let's take a look here. Here's another example of base AB. A is to the exponential power of 2. B is to the exponential power of 3. Both of these a's are to the power of 2. Both of the b's are to the power of 3. AB squared and cubed, AB squared and cubed are like terms. So what does that mean? I can add or subtract these terms in front. Negative 2 plus a positive 1 gives me negative 1. A squared, B cubed. A squared, B cubed. All right, so that's a quick review of like terms. I'd like to get into another example of FOIL. And this will be the last example of FOIL, and then I'll be getting into different types of factoring in the coming videos. So here we have 2x minus 1 times a quantity of x plus 1. Remember FOIL, right? We're going to check and make sure this factor, the terms that I factored here, 2x minus 1 times x plus 1, gives me the same expression or equation I started with when I first started to factor. So first term times first term, 2x times x. Outer term times outer term, 2x times a positive 1. Inner term, negative 1 times x. And the last term is negative 1 times a positive 1. Again, I'm not trying to fool anybody. I'm using very easy, friendly terms. Okay? So I want to show this to you now. First term, that's the 2x times the x. That's a 1x raised to the first power. This 2x is also raised to the invisible 1 power. Remember, when we multiply, we add those exponential powers. I'm going to add a plus sign between the next two terms, and that's going to be 2x times 1. 2x, that's my outer term. 2x times the 1. I'm going to put a plus sign here with my inner term. That's a negative 1 times x, or 1x times a negative 1. Put a plus sign in between my next terms. I'm going to multiply the last term's negative 1 times a positive 1 here, you can see. Now I'm just going to simplify by multiplying, and then I'll combine like terms, and then I am done. So as you can see here, 2x times 1 is 2. Plus 1x times a negative 1 is negative 1x. Now there are no other x squared terms, so I'm just going to bring this down and rewrite it. I bring down my plus sign. I'm going to combine like terms. 2x plus a negative 1x, or 2 minus 1, is 1x. Bring down my plus. There's no other whole numbers. I bring that down. I have completed my FOIL. The term, the expression, excuse me, or the equation I started with, 2x squared plus 1x plus a negative 1, should be the expression I began my problems if the factoring 2x minus 1, x plus 1 is correct. Again, FOIL is checking your answer. You'll see that later as we go over some of these problems if you haven't seen it already with me. This should have been the problem you started with before you began to factor. And of course, that's how you check your answer. Thank you for joining me. Math is easy. Take it step by step. If I've helped you with some of these videos, please help me. Thank you for joining me.